All right, so this is again for worksheet 12.2, but this is now part 2. Determining where two lines will intersect, so R1 and R2, and trying to figure out time 2 for when they'll be at this location, and time 1 when this equation will be there. And then determine whether or not they will intersect or not intersect. So whether or not they're going to crash or not. Okay. All right. So first off, so let's start off with two equations here. So let's say you have R1, which means this is going to be T1, and my slope is 1, 2, 3. So at time 1, I have a direction. Excuse me. This is my point 2, 3, 4. Oops. Excuse me, this is my point. Okay, and this is my slope. Okay, so R2, so this is time 2. So my point is 3, 5, 7. And my time 2 would be -4, -6, -8. All right, so first thing, you want to do a quick check to see if whether or not they are parallel. Now, they might start off different times, but they're flying or moving in this. Okay? So look at your slope. So if you look at these values here, that will tell you this. So if you have 2 over -4, 3 over -6, 4 over -8, notice all those imply a direction of -1/2. So they are going the same direction. Now, however, though, you could have something like this, but you could also have one trailing another one. So it could be following the same path. So it could be either one of these cases. So let's go through and solve it and see what happens here. So what we got to do here is separate the components. So my first component here will be 1 plus 2t. And we got to keep track of the different times. So we got a t1. And then 3 minus 4t. That'd be times t. And let's find my y component. And that would be 2 plus 5t, 1. Excuse me. 2 plus 3t1. And 5 minus 6t2. Okay, now I do also need my z's, but I'm going to use that one to check after I solve. Okay, so my z component is going to be used to check. Okay, all right, so let's come back to my x component here, and I want to clean this up here. So I'm going to have 2t1 plus 4t2 equals 2. Okay, on my y component now, I'm going to have 3t1 plus 6t2, and that is going to be 3. So what we have here is two equations, two unknowns. So let's change color here. So if I move this over here, and this is 3t1 plus 6t2 equals 3. Now you're used to seeing x's and y's here. Now it's just t's, t1 and t2. All right. So what we got to do here is try to eliminate one of these values. So I'm going to eliminate my t1s. So I'm going to multiply this whole equation here by -3 and this whole equation by 2. All right. So what will I get here? All right, so this one here, I'll have -6t1 minus 12t2 equals -6. next equation here, I'll have 6t1 plus 12t2 equals 6. So I got 0, 0, and 0. So basically 0 equals 0. So that would mean this is like an all solution. So what that means then is they are the same equation, somewhat. So what this is okay, you got one equation here, and then you got a second equation following the same path, like so. Like that. Obviously they're starting at different times. This would be, let's say, time 2, and this here is time 1. So then we could determine, how far apart these two values or particles or planes or whatever, how far apart they are behind each other. Okay, so do I need to use Z to check? No. Okay, Z to check is when they're going to intersect. Okay, so let's do the other combination. Okay. All right, so let's say my R1, T1. Okay, so my point here is 1, 3, 1. And my T1 is 1, -2, -1. My second equation, so T2 is -1, -3, -1. And T2 would be -1, 2, 1. All right, so again, let's check my slopes. So if you look here, we have 1 over -1, -2 over 2, -1 over 1. So they all imply a slope of -1 over 1 of some form. So they are, again, you got the two different combinations, either this one or one on top of the other one. So actually it's going to be this scenario here, because we just did this one. All right, so let's break it down into our two components. So my first component would be 1 plus 1t1, and that would be then equal to -1 plus -1t2. Okay, my y component would be 3 minus 2t1 and -3 plus 2t2. Again, if they do intersect, I'll use z components to check. All right, so let's clean this up here. So what I have here is 1t1 plus 1t2 equals -1, or actually -2. My y component here, -2t1 minus 2t2 equals -6. Okay. Now, moving this over here. Okay. So I have -2t1 minus 2t2 equals -6. Okay, so now if I multiply, let's say, this one here by -2. Okay, that would be -2t1 minus 2t2 equals 4. And now this equation here, actually I should have been just positive. Let's come back here. Positive, positive, negative. And now that I have -2t1 minus 2t2 equals -6. So here cancel, so I have 0 equals, but now I have 0 equals -10, which means no solution. Back to Algebra 1 days there. So what does that tell me then? Is you have something like this. Okay?
So they're flying side by side, again, probably at different times. You have T1 and T2. So, you know, this object's particle flying here, this particle moving over here. So it's in that case. So again, I don't need my Z component to check because there's nothing to check. Okay. All right, so now let's do where they do intersect. Okay. All right. So you have R1, so T1. So you have 1, 2, 3 plus T1. So I have 3, 1, 4. Then my second equation, so this would be T2. And my point is 2, 9, 11. And T2 would be negative 1, 3, 2. All right, so breaking it down into components. So again, my x component. So I have 1 plus 3t1, 2 minus 1t2. My y component then would be 2 plus t1 and 9 plus 3t2. All right, let me just double check everything. I think we're good to go. All right. Now again, we will use Z components to check. Okay. All right, but I'll write those down later. So let's go ahead and clean this up. So what I have here is 3t1 plus 1t2 equals 1. My y components here, I have t1 minus 3t2 equals 7. All right, so let's move this one over. So I have t1 minus 3t2 equals 7. So let's go ahead and multiply by what? Let's multiply this one here by negative 3. Okay, so this one here, nothing's going to happen to it. So I have 3t1 plus t2 equals 1. This one here would be negative 3t1 plus 9t2 equals negative 21. So therefore, t1's cancel out. So I have 10t2 equals negative 20, and my time 2 is negative 2. And this could be like seconds, minutes, hours. Depends on what you're dealing with, particles, time, and all that. Now, I still need to get my T1, so I can go back. I'm just going to do it here since I have space. So T1 minus, actually plus 6 equals 7. So T1 is 1. Now this is where I need to come in with my Z component now. Okay, make sure everything works. So my Z component is 3 plus 4t1 is equal to 11 plus 2t2. Okay. And cleaning this up, I have 4t1 minus 2t2 equals 8. So thrown in my times here and here. This here would be 1, and this would be negative 2. Okay, so if I plug that in, I have 4 plus 4. So notice we have 8 equals 8. So it checks there. So now let's look at if I wanted to find where they will intersect. Then I can use either equation. Okay, so if I had my, let's say R1 T1, and I had the point 1, 2, 3,
and T1 of 3, 1, 4. So my x component, so using the time of T1, see, my T1 was 1. So my x component would be 1 plus 3, so it would be location of 4. My y component would be 2 plus 1, so it would be 3. And z component would be 3 plus 4, or 7. All right, so you have two things crossing here. Okay, so R1 is going to be at this location of 4, 3, 7 at a time of 1 second. Our equation 2 will be at this location. So they're traveling here. They're going to be here at time 2 of, what did we say, -2 seconds ago. Okay, so notice a gap of 3 seconds apart, or 3 minutes, 3 hours, depends what you're doing. If it was planes, 3 seconds apart, it'd be awful close. 3 minutes, not bad. All right. Okay, so let's do one last thing with this. Okay, so if you have let's say R1 of T1, and you have 1, 2, 3. Oops, that's my point. Plus T1 and 3, 1, 4, and say R2 T2. You have 2, 9, 11, and T2 you have -1, 3, 2. At what angle are they approaching? So again, this is a little review. So remember, you using the dot product. So R1, the magnitude of this, times the magnitude of R2, cosine of theta, and the dot product by components, like so. So to do that, we got to find the magnitude of R1. So our magnitude of R1 would be the square root of 9 plus 1 plus 16, or root 14. Oops, excuse me, 1026. That's for R1. R2, the magnitude of that one would be root 14. So therefore, plugging this in, you have root 26, root 14, cosine of theta. The components you already have, so you have 3, 1, 4, dot, -1, 3, 2, which I do believe gives me 8. Divide that by root 26, root 14, and therefore the inverse, so you have right around 65.2 degrees. So now we have a whole lot of information here. We know the angle that they are approaching towards each other. We know the times that they will be at a certain location, and all that. All right, so that's it. So